So my name is David Cramer. I'm going to talk about some kind of common practices and misconceptions about what scaling is and why it's not that hard. I came up with this. I think it's pretty clever. The things we build will not and cannot last. And I specifically mean this with our applications. We're not building an application to last 10 years. Technology moves much more quickly than that, so we don't need to focus on how it's even going to be in 2 years. Who am I? I built Celery. How many of you use Celery? Need a few more hands in there. You should use Celery if you don't already. It's an open source Django application that manages event aggregation very, very well. If you have an error, it tells you exactly why you have an error. Until this week, I worked for Discuss. I actually have just joined a new company. Discuss powers comments on every website. It's a very, very large Django web application. They do about 1 billion unique visitors across their network each month. And I now work for a company called 10xer. And it's very different from Discuss. But what we're trying to do is measure a bunch of things about how engineers work. Which just means a lot of data. So what do we mean by scale? Well, there's a lot of things that scale can mean. Each of these has very different scales. Discuss is a very, very large network. It gets many, many requests a second, tens of thousands. And it has the long tail problem, which means that every single page that loads Discuss cannot be stored in memory because there's just too many of them and maybe it only gets loaded once a day. Celery has an interesting problem, and that's that it tries to do counters and aggregation purely in a SQL database. And 10xer just has an enormous amount of data. So here's a question to ask yourself. Can I take somebody's solution, like many of the solutions I'm going to present with you today, and can I apply it to my problem? Well, most of the time, the problems are very similar. So yes, you can. So Discuss, built on Postgres. Everything lives in Postgres. It uses a lot of other technologies, but that's the fundamental storage system. 10xer has a simple graph database that's written on top of MySQL. And Celery more or less works on any SQL engine. The common thread here is they're all SQL. So the database is not your problem. If you can make it to the size of Discuss, you can find new problems. You can switch off of SQL, but you should not be worrying about that. So let's compromise. So we want to be able to predict what's going to happen. This is the fundamental issue with scaling. We want to know that when we grow 10x the size, that the system's going to behave in this kind of fashion. That can be very hard to do with things like SQL, with traditional database mechanisms where you have to store everything on a single node. But it's not impossible. So what we choose to do is we take the database and we just add additional layers to it. Many of the tools I've used or Discuss has used in the past, Redis is by far one of my favorites. Memcache, Discuss is exploring Cassandra now. It's used for various things, but it's very complicated. React is also a very interesting take on things. So I'm going to talk about a bunch of stuff using Redis. It's the only technology that I'm going to use to show off any of these examples. It's by far one of my favorites. It's a database that requires everything to fit in, doesn't require, but needs everything to fit in memory. And it's pretty easy to get started with. It's simply install the package, run it, and you're good to go. So the first off is counters. How many of you have counters in your application? Okay. They literally are everywhere. A graph is just counters. We've got some simple stats about my Discuss profile, just counters. The Celery aggregation counters. It's literally everywhere in your app, and it can be one of the most annoying problems to solve with performance. So this is generally like step one. If you're going to use a database, you just do an atomic update, counter equals counter plus 1. Works very well. The only time this becomes a problem is when that counter is being updated very, very quickly. To show how easy this is in Redis as well, if you were, for some reason, already storing this in Redis, it's just an anchor command, exact same outcome. And this is how we solve the issue of counters. Sentry, for example, this is, hopefully that's legible. What it does is events come into the system. Say, we'll use people. Say there's men and women, and we're trying to count the number of men and women, and they're just coming in very, very quickly. We need to say, every time there's a man, increment the man counter, and every time there's a woman, increment the woman counter. So Sentry does this with events. And if you're updating that man and woman counter over and over in the database, you're going to have row locking contention, which is, it's basically going to cause your write to wait on every write before it. So we solved this with kind of a clever hack using Redis. We use it as a counter buffer. So every time an event comes into the system, we incur a Redis key that's specific to that group, not the specific event itself. So if the event is about a man, we're going to increment the man key in Redis. And this is very fast. Redis is all in memory. And if it was a problem, you could scale it out to more Redis nodes. Anyways, now that we have a bunch of these events coming in, all incrementing the man counter, then we compile all those into one SQL update statement, which again is very fast. So some notes on how we do this. Simple anchor statement, just like I showed before. And then to make this actually somewhat scalable, we queue the SQL update. So an anchor comes into Redis, and then we fire up a queue job. And Celery has a bunch of stuff. How many of you use Celery? Okay, we're going to talk a little bit about that more later. But it has a thing that you can set an ETA. This isn't a traditional queuing mechanism, but it's something that it supports. And so what we do is an anchor comes in, we say in 5 seconds, take all of the anchors and update the database. And what this literally means that every time there's an anchor statement that we send to Redis, we also fire a job in the queue, which is a problem, and I'll explain why in a minute. So when that task gets fired, we get the event, the aggregate ID, the man counter, and we delete it all in one command. It's fully atomic. Redis is single threaded, so you don't have to worry about a race condition here. And then we no-op if that counter returns a 0 or none result. So what this means is that every single one of those tasks that came in are effectively getting no-opt for the man counter, except one of those for every 5 seconds. So that should give us one SQL update for every 5 seconds, which SQL can scale very, very, very far. And you more or less just solved counters by replacing it with a different problem, which is that you now have a bunch of no-ops in your queue. But it's a much easier problem to solve. So again, this is focused on row lock contention, which is the only thing you need to avoid. Redis is very easy to set up. You can just add more Redis nodes. They don't need to share any kind of state. It has a master slave if you need HA. And it's very easy to implement. So I talked about how the no-op tasks were kind of a problem. So this is something I've been thinking about because it bloats the size of your queue and it's kind of hard to understand. Like if you have 1 million items waiting to be processed, how many of them are actually going to do something? So we lose that predictability aspect. So one other solution is Redis has sorted sets, which are super, super nice. What you could potentially do is every time an update for a man or a woman comes in, is you anchor a key in that sorted set for man or for woman, which means you have a single key, and then you have a simple, like, it kind of looks like this, sorry. It actually really, really does look like that in Redis. And then what you're going to do is, like, every 5 seconds is what we said before. Maybe you pull down that key, wipe it, and you anchor the database, just like we were going to do before. So there's some annoying issues here in that nothing really supports cron in like a queuing level. Celery has support for this, but it works like traditional cron, if I recall correctly, which means you're going to be able to do it like maybe once every 60 seconds. You can get around that by not using cron, have an infinite loop running. But this works really well with the downside that that you're going to get a large sorted set key, but they're very efficient in Redis. So if you're breaking that up, which you could as well, you basically eliminated all the issues with the counters there. So say I know that my number of keys is going to be very large. So say I'm sorting men by their age, and 100 is too many, and we get 1 through 100 ages. So I could say ages 0 through 10 are going to go here, 11 through 20 are going to go here, and then you split up your length of the set scaling issue. And then we have a much more predictable system because we know every 10 seconds we're going to get this SQL update for every one of these rows. And again, it's only one SQL update, which is going to cost you nothing. So another big, very, very common thing are activity streams. And this is kind of an interesting thing because the common activity streams look like this. You know, you've got like Facebook newsfeed, that's an activity stream. Twitter is an activity stream. But many products are actually just streams of data. They're just a list of items in them. This is actually much more complicated to solve than counters. And this is kind of what it looks like in the database for Sentry. We simply have an event, what the event type is, maybe some arbitrary data, the user, and the date. And then we end up with a system that understands events and just will render them like this. Now, this is not the canonical source for what happened. Like, we have an event called setResolved, which is when something becomes resolved in the system, but that's not the only place that we know that that event is becoming resolved. So what this effectively is a denormalized view, or a cache of what the actions were that happened. And so when you start thinking of it that way, it tends to fill in a lot of gaps in how you can speed up things and improve performance. This is an example of how you might do this in Python. You should probably never do this. But it's effectively what Twitter's stream would look like, right? You have a timeline. Every time an event comes in, you're going to insert it to the top of the timeline, and you're going to probably trim the timeline. It's very inefficient in the sense that trimming the timeline is expensive, especially at a larger level, especially when this is not in Python and it's in your database. But fortunately, we can do things like that in Redis as well. We can go back and we can use those sorted sets again. You'll see here, I'm just using the Python Redis library, and there's a zadd command, and we're inserting to the timeline key and the event ID. We're only storing the event ID. This is actually important. And the score is just the timestamp. And what that means is we can pull them out. We're doing a zrev range, which is ordered by descending, and we're just pulling out, like, say, the last 100 event IDs. And then once we have those, we can look them up wherever we need to. We can create a database for the actual event data. One thing of note, I mentioned you need to trim it. So again, Redis is super awesome for atomic writes because it's single-threaded, and you can actually send a bunch of commands at once. And this is how you kind of do that with a pipeline. So it's just a simple context manager. You're calling the add, and you're calling this rem range, which is, it's kind of complicated. I'm not exactly sure how the math works, but we're saying trim it down to 1,000. It's like a start and then an offset. But anyways, this is all a single command that gets sent to Redis. It's all very, very fast, especially as long as you constantly are doing it. One of the next big areas, and I don't think people do this nearly enough, is queuing. And there's many ways you can queue things, and I don't just mean you have something slow or something, or a background task, just put it into the queue. That's definitely not enough, but that's how you get the infrastructure in place. Again, I mentioned Celery. That's what I generally use. I think it has a pretty, I wouldn't say a steep learning curve, but there are a lot of caveats with it. I've yet, for example, to make Celery work with any kind of concurrency successfully. And generally, you're going to want to use it with RabbitMQ or Redis. And I would say RabbitMQ 100% of the time, but if you're just getting started, you can just use Redis, especially if you're already using it for other things. And this is actually interesting because the way we built Sentry is that you can kind of augment the architecture as you need to scale it up more. So you can start with just a simple database. You don't need queuing. You can turn on queuing, turn it on for Redis. You can turn on the counter buffers. They already use the Redis stuff you have. And then, as you grow, you'll have the issue with Redis that it needs a fit in memory, and a queue, the idea is that it can back up if you need it to, and then you can just process the jobs very quickly to get it back down. And if you have this in Redis, you're eventually going to run out of memory, so you effectively destroy the machine and destroy your queue. RabbitMQ does a much better job at this, and it's very fast. It's a little bit complicated to set up, but it's not too difficult. This is kind of what it looks like, a simple example of using Celery. We're registering a task here, and it's just saying when an event is created, we want to increment this counter. One thing of note here, and I could be completely wrong about this because I still cannot wrap my head around AMQP, but we're binding this task to this very specific exchange, and I think this is important. A lot of people make the mistake, and even I continually make the mistake, of binding all of your tasks to an individual queue. By default, if you just wrap something in task in Celery, it's going to bind to the default queue, which is all fine until you have a problem or you need to see what's going on. this specifically, if we had every task in its own queue, we could see, oh, the number of event creations is backing up. Maybe we need more workers just to execute those tasks. Or maybe it's like you have a low priority queue or a high priority queue. But I highly suggest, maybe not necessarily every task in its own individual queue, but at least every set of tasks that have a concrete purpose. And one other interesting thing, early on at Discuss, one of the first things I did there was I refactored a system that we called Importer. And what it does is it takes a WordPress XML file, or actually it takes many WordPress XML chunks, and it inserts them into the system effectively to import comments. When I joined, it was basically a while true loop, iterating, I think, a directory on the file system. And it did not scale at all. The machine would die, it would never get updated, we didn't have enough CPU. And so we quickly rewrote it to use our queuing infrastructure. And it somewhat resembles this in the end. You'll have a job that comes in, it's like import XML, okay? It just says, here's the file, deal with it. And what that job actually does is it parses it. And then from that parsing, it might split it into segments, and it'll fire another job with each of those segments. So we're effectively fanning out that queue process. Each segment then will say import this individual comment. So that could mean this one individual task turned into millions and millions of tasks. And again, this makes it nice because we have a more predictable system when we know that there's this many items that process versus one very long running task that's just looping over everything. And again, this is the same kind of example. We have that same on event creation, we want to anchor the counter. And all we're doing is we're saying now that we have a global counter and an events counter, we want to delay a task that increments both of those. Very simplistic, if your counters are fast, this wouldn't make sense, but you should kind of get the idea. One other thing I mentioned, in the sorted set in Redis, in our activity stream, we were only storing the event ID. Now this can be a problem. It won't appear very early on, but let's just say you have 100 event IDs that you're pulling down from the cache. They're ordered and everything, so you don't have to worry about that, but you need all the data for them. So what you might do is you might say, query my database, give me all the rows where ID is X, like an ID in X query. It works pretty well. Most databases are pretty fast to respond to it, but generally things are going to fall out of memory very quickly, and then they start getting expensive. So we solved this with something that might have a better name, but I call it object caching. And these are kind of the things you need to think about before you even bother with this. Can your database handle the read load? Well, this is why we're implementing this first off, because it can't anymore. If the data changes infrequently, this is super valuable because it no longer needs to be a cache. It can be a representation that's persistent. And you can handle slightly worse performance, but I mean that the smallest amount. It's not going to be faster than it would be just querying a database that could handle the load. So what this might look like, say we have a memcache. So we have a cluster of 3 servers just to distribute the things in memory. We're going to have a bunch of keys that are event ID 1, 2, etc. And that key is just going to store a serialized state of that event. And that means when it comes down to it, we have those lists of IDs. We can have this simple get by IDs function. And all it's going to do is it's going to pull down all the objects using a get multi. Oops, I forgot an argument in there. It's going to pull down all the keys in bulk. This should work most of the time. Let's just say in theory that get multi works. In practice, it works much less. But it's going to pull them down. It's going to find any results that return a miss. And then it's going to query the database again for those, and then it's going to set them back in the cache. It's pretty straightforward. It effectively gives you a very simple system to store representation of your object. And more importantly, when things update, you can immediately serialize those into the cache. This is something that was very effective at Discuss. We actually laid this over the ORM, and you did many queries. Say a common one on Discuss might be what is the website, or I have the website slug, which is CNN. Give me the website's information or something, right? So every time that gets saved, we're just going to serialize that in the cache because it's not changing that often, and the cache is much faster and much easier to scale than our database. And then when it gets deleted, we just delete it. Now, one thing to note that I don't illustrate in here is that deletions can actually cause a lot of issues. Deleting them from the cache may not be the best solution. It depends on how your system's architected. For example, if I had that list of event IDs and I assumed that when things are missing from the cache, that it's a miss and I'm going to query the database, then effectively what I'm doing is I'm causing a stampede effect that's going to continually query the database because I deleted this key and I didn't update other relations. So what might be more effective than this is setting what people call a tombstone value, which is insert something arbitrary, like a -1 or something. And if that comes back, you just say, you make the assumption that that means it's a deleted value. So one improvement you might make, since we're already using Redis everywhere, is just persisting it using Redis. Same thing as memcache. It's still effectively a cache, but you could serialize it to disk, which means if your Redis node goes away, now you're going to have issues if your Redis node goes away, which I'll talk about in a minute. But if it goes away for a blip or you have to restart it, it could effectively just come back online and it would have all that data still in the cache. Now depending on how you're doing hashing, that could mean very bad things in your system because it could now have out of sync data and there's no easy way to repair that. But it also means that you can effectively store things forever and not have to worry about NLRU or evicting them or any other constraints. That said, I would probably just stick with memcache because it is much better for those kind of things. Something else we wrote to discuss early on is called Midas. Does anybody use this? Okay. It's a very easy library for managing, originally managing like a cluster of Redis servers. It doesn't do any magic for you, it just handles routing. So for example here, we're creating a cluster of database servers that are using the Redis backend. They use a simple partition router, which is it's just giving a hash on the key. And we're configuring 10 DBs, which Redis has this concept of a DB, which is like a table space. It's within the same Redis instance, and it's easy to illustrate. I wouldn't actually recommend using it. Instead, what you would probably want to do is have a bunch of actual Redis servers running on a machine, and you would just have the different host names in here. Anyways, we've created a simple cluster there, and it makes it very easy to manage a bunch of nodes and like spread out your queries to the correct location. So, I talked a lot about simple solutions for some of these problems. There is a much better solution for all of these problems, and that's better planning. So on Discuss, we have this moderation page. It's basically, it lists every comment. Actually, it just lists every comment, period, on your website. More importantly, we have this All Sites section, which is listing every comment on every single one of your websites. And this has been one of the largest and most time-consuming issues at Discuss. It suffers from many problems in that the queries can be complex. You'll see at the top here, there's a bunch of tabs. It's all approved comments, pending comments, spam comments, which means we have a bunch of different scenarios for what kind of data you need to display. More importantly, it pulls it from every single website. You can be added or removed from websites arbitrarily. So that means if you're a member of 100 websites, we all of a sudden have to say, like, select all the comments where a website in this range. And this is still using a SQL database at this point. Now this gets very hard to deal with because effectively you could maybe cache or you could just shard the data by the website and you could distribute your reads that way. But the global view has caused us far too many problems. And that's because if we shard by website, now like how are we going to query all of them? If I'm a member of 20, 30 websites, which isn't common, but it's not uncommon, how am I going to get all that data? I can query it in parallel and pull it down and merge it in the application. But that means like it's effectively end queries to the database that pull that down. So the solution, again, this is just an activity stream, just a view. It's a very complicated one, especially with the aspect that people join and leave a view, so their stream of events needs to change. But that's all it comes down. Rather than trying to explain how to solve this because it is still unsolved, this is one of the things that we are attempting to use Cassandra for. What might be better is to not have it as a feature at all. If you could, not the moderation in general, but if you could just eliminate that all sites page. Now effectively, we can distribute data based on the website. It means like we might end up with hotspots if, say, all of CNN and Fox News and a majority of other popular websites all end up on one node, but we could fix that by saying we're going to explicitly route them to this other node. But when we need to show all data across all forums that a user is a member of, like we can't do that anymore. So essentially I explicitly have planned for growth that I don't want to deal with. So we have a dashboard in Sentry, which is the only place where it shows any kind of reasonable aggregate data. And it shows a graph of all the events across all your projects, but for a single team. And it shows like this trends view and this new events view, but it only shows like the highest scoring 5. So it's just an activity stream of 5 events. And that could easily be cached. So, and it's, again, it's the only endpoint that aggregates any of this data. And it only aggregates it on a per team level. More importantly, this is the stream view. And there's no per team stream view. There's no per user stream view. There's no per user dashboard. There's specifically only this for a single project, which effectively means that a project could live on its own database if it needed to. And when we get to talking about having multiple databases, one of the most important things, and in fact I would say the only way you should ever do this, is by pre-allocating where your data is going to live. For example, let's just say this is Redis 1 is actually a physical machine, okay? So it's got 9 databases on it. Let's say they're just all running on different ports. This is a very common thing we didn't discuss. We ended up with probably several hundred virtual Redis servers, and we only had a few physical machines. Now the nice thing is, when that machine runs out of memory, which it will do, all you have to do is migrate those actual instances to another physical node. You don't have to worry about migrating the actual data somehow. You don't have to go through and say, oh, I'm going to take all these rows and I'm going to put them on this server, and I'm going to take all these and I'm going to put them on this server. You're literally just syncing over some files and you're cutting over. It makes it very, very easy. And now again, like 10 is not a large number. I think we did 32, which is still a small amount, but it was based on if we could have 32 of the largest possible servers we can get, would that be still plenty big? And the answer is yes. So that's something to consider. But you can plan ahead for it. 10xer has tens of thousands of shards that we planned ahead for, and a routing table to pipe to each one of those. And it makes it very easy when you need to cut over. So some things that I want everybody to kind of leave here with. SQL works just fine. You don't need any of these other technologies. Most people are never going to reach the scale of Discuss. Even Sentry isn't anywhere close to Discuss. But it has very specific problems that need solved in a very specific way. Sentry is not sharded right now. 10xer is sharded, but the data could technically live in one location, but we know that the data size is going to be so large that it can't. It's the only reason we've taken that step. But it's still all SQL, with a few things that help it. Put everything into the queue. I'm not a huge fan of queuing requests. Armin has some thoughts on this, I think. But if you have anything that doesn't need an immediate response, put it in the queue. If it's, it could even be discuss comments. When you create a comment on a website, do we need to show that to the world immediately? Probably not. Like, we might need to show it to you because you made it, and if you don't see your comment and you reload the page, you're going to be like, why is my comment missing? Do I need to post it again? But we could do that by just storing it in a cache key. Effectively, we could queue almost any action. We can queue creation of a comment. We can queue voting on a comment. We can queue anything that happens in the system other than, hey, we want to see the comments for this web page. Most importantly, learn to say no to features. Just because somebody wants a feature doesn't mean it's worth your time. You consider, there's the costs that go to building it, first off. And those costs might be easy right away. Like, I could easily add to Sentry, a global stream per user, and it would work just fine until the database became a bottleneck. And then I'd have to deal with, well, am I going to delete this feature, or am I going to somehow make it work? And making it work is very expensive. We've spent a lot of times on various systems at Discuss to try to optimize features that we can't take away anymore. The global dashboard, or the all sites moderation view, that can't go away anymore. People expect that to exist. People may have chosen the system purely because that exists. If it wasn't there, they may still have chosen it, but you can't take it away. So I think it's very important that you say no as much as possible until somebody makes a very good case for something. Complex problems do not require complex solutions. I hope all of these examples were pretty straightforward. Sentry has tens of thousands of events coming in every minute, and it uses commodity hardware. It's not a crazy complex system. It's just simple counters, simple Redis stuff. Even Discuss's counters for the longest time were just stored in a bunch of Redis nodes. They're all denormalized. They're never the canonical source of things, but it's a very fast way, an easy way to get stuff done. And then when it becomes a problem, which it did 2 years after we built the system, then you can go back and you can spend more time building it, because hopefully your company has grown to where it's more valuable at that point. And that's all I have for you.
Thank you very much. And now to the questions.
In a company with managers, with developers, with architects, who should say no to things?
It can be very, very hard sometimes. Not being a product person specifically myself, I always push back a lot when people want something, and I try to at least get them to answer the question, why is this valuable? Like, does it have business value? Like, if you're a customer-facing app who makes money based on some features on your website, somebody's paying to use your service, are more people going to pay for it, or are they going to pay more just because you add this feature? Like, I think it's unique to each organization, but I think it's important to at least explain to people in your organization when something could be a problem if you build it. And that's obviously more apparent when you have a huge data set like Discuss that's trying to deal with performance and optimization already. But just consider, like, if you expect some kind of growth, how expensive it would be to maintain or to expand on this feature in the future, and try to sell that to people.
More questions?
David, at the beginning of your presentation, you said that SQL is not a problem, but in a real world,
Many things in SQL are a problem.
as I know, Discuss and Sentry based on Django, and it uses a relational database for its main storage. Okay. My question is, when we have a database with some replication setup and so on, how to integrate this deployment to Django? Is there some applications, some libraries for this task? And concretely in the Discuss and Sentry, what do you use for this?
Are you talking specifically about, like, if you have a slave or like a failover?
Master slave, yes.
So don't use slaves. Simple answer. I am 100% serious. Discuss is sharding architecture. The only reason slaves exist is for redundancy. So if a master fails, we can fail over to the slave, and your application could handle that, but the way we were building it, the application would not be responsible for failover. We'd be connecting to a persistent like IP address that's virtual or something, and when failover happens, the application needs to understand that the connection may be lost and maybe it needs to gracefully fail. But other than that, it doesn't need to say, oh, database is gone, I need to switch to this one, or oh, is it in read-only mode? Those features are useful, like read-only, for example. We've used them many times, but the fundamental way you use your data and store your data, I think you should try to eliminate those problems, because replication, huge, huge problem for Discuss. And the only way we solved it was by getting rid of it. Because like you can't, once you have master slave, if you're relying on that one slave a lot, like you can't just keep adding more slaves. Like you're done at that point. Like you need to fix the master database problem. And that's why I'm saying things like, if you can eliminate writes to the database, like Sentry will blow up if you do not have the counter buffers enabled, because there's just so many writes to the same rows over and over. Like if your website goes down and they all generate like a database error, it's going to send all of that to Sentry, and most of that's going to be one event. But realistically, like, we don't need to do an update every single time that event comes in. So find ways to like optimize like your write patterns. If it's just read that's your issues, like slaves can be useful for like analytical queries and stuff that's slow. But like try pushing it to a cache or something.
At our company, we use Sentry, self-hosted Sentry in our infrastructure, and it doesn't work with the multi-master setup out of the box. We have to use the master slave application to handle master database outage.
Is it MySQL master?
Yes.
Okay. I actually haven't used. We use MySQL at 10xer now, but I haven't used MySQL in 3 years. So I'm not too familiar with how all that stuff still works. In Postgres, it's I think probably similar, but again, we would just fail over using the system side failover versus the application side. So multi-master, we're just going to point to that one location, and that's always going to be our canonical connection for how we get to the database. And that's how we would solve it.
Okay, any more questions?
I was actually just curious whether Discuss was running on EC2 or if you guys have your own hardware.
I'm pretty well known for hating the cloud. Discuss does not use the cloud except for S3 and EC2, specifically for doing like MapReduce jobs on, I don't know, access logs, for example. And that's just because it's so much cheaper to use EC2 when you're hosted on S3 than it is to have your own hardware. But it's all leased servers. And my argument for that would be that they do not have terrible hardware. Like Amazon is well known for having, disk I/O performance issues. Now you can probably get rid of most I/O in your application, but you're always going to have issues, especially with your database layers. And so on top of that, Discuss servers, most of the databases have half a terabyte of memory, so it won't fit on EC2 either way. I think they still limit to 64 gigs or something. And now technically sharding could solve that. That's how Instagram solved it. But why deal with that when you can just get better hardware that will delay that problem until you have maybe more people or more success where you can invest into it?
Yeah, I was just curious how you actually got away with not doing replication. And so that makes sense.
Yeah.
You actually have the hardware to support
Yeah.
the single master thing.
We do, the legacy database server at Discuss, which is still the primary data source for most things, does have 12 slaves, but they cause problems a lot of the time, and most of those are not used in the actual read pool from the application. And we explicitly would say, we are okay with this being slow, we're going to read from the read slave.
Any more questions?
David, what kind of data do you analyze and 10x? What's the idea behind the project?
The goal is, I'm getting better at explaining this. If you've seen the movie Moneyball, that is the goal. If you haven't, the gist is that if we can tell you what kind of metric would help you succeed more, if you could set a goal, I don't have any good examples because we're still dogfooding and feeling this out, but one example is, let's just say you knew that if you wrote patches with 150 lines of code or less, that you caused less bugs, or you increased the amount of code that's written a week, or something along those lines. You could set a goal, and we could point out that that is a goal because we have all the numbers that show it. And you could say, I want to achieve this, help me get there or something. So right now all we're analyzing is mostly engineering related stuff. So for example, GitHub, we integrate with GitHub, we pull down all the commit data, we track a bunch of stats on it. We don't know which ones are going to be very effective yet, but we get lines changed, we get number of patches, we get, one that is interesting that we're dogfooding right now is how many patches do you submit versus how many patches do you code review? If I'm submitting 10 patches and I'm only code reviewing one other person's patch, I'm effectively creating more work for the rest of the team. And just having that insight in your face, even though it's not necessarily something that you could react on directly, it's good to know that you're doing that and that could impact the workflow of others. So yeah, the answer is we're measuring everything, we're collecting a lot of data. We don't necessarily have the solution yet.
How do you manage server infrastructure and Discuss?
Discuss.
And the second question, how do you perform live migration of the Redis nodes, database nodes
Yeah.
under load?
I forgot to include that slide. So the first question, how do we manage infrastructure? Simple answer is we just use Puppet at Discuss. Sentry uses Chef. 10x will likely use Chef. Right now it's still shell scripts, and it's on AWS, so you can clone nodes and kind of get away with having not invested a lot of time yet. But I highly recommend just using one of these tools that exists, Chef or Puppet. I think I prefer Chef, but to each their own. And schema migrations or DDL, I have a good blog post which illustrates this a little bit better. My website's justcramer.com if you can find it, or it's on my Twitter profile. But The gist is, when you add a column, it has to be null. It cannot have a default value. If you can't add the column under those conditions, if the write load on that database, or that table, for example, is still too much that would time out or not complete or would cause replication lag or anything that is a problem, you would have a master failover scenario. So you would make the changes on the slave, and they all have to be compatible. Like, that means that, first off, null is in Postgres very fast to add as a column, or a column that's null, rather. More importantly, that makes it compatible. Like, if the application needs a column to be there, it's there and it's null. You know, like it can get away with not saving data to it. If the application doesn't need to be there, it doesn't matter. It's like the data is just going to get ignored anyways. So that means if you have a code change that references the column versus doesn't reference a column, you're okay. So anyways, you make the change on slave usually. You don't migrate any data at this point. You just make a schema change. Then you promote the slave to the master, do the same thing on the old master, and you're basically done. And then you'd have a follow-up step, which is now I need to migrate existing data, if that's your case. So maybe it's like, I need to store a count of something, so I'm going to go over everything, and I'm going to start counting it. And generally, like, there's a lot of complexity here, but like, it generally, like, do something in your application to start the migration that is like a write ahead, and then backfill the old data, like, once you've started migrating. Like I said, lots of complexity to it, so it's hard to explain without a lot of information. But yeah, that's the gist of it.
Thank you very much.
Thank you.